Welcome to all of you. In this session, we are going to understand how to separate even numbers from the given set of values. Let us go through the question first. Write an ALP to separate even elements in a given array. So let us first understand the procedure of identifying the odd numbers and the even numbers. So let us consider an example for that. So we are going to have 5 numbers with us, that is 0, 1, 2, 3, 4 and 5. Now among these numbers we need to separate out or we need to identify first the odd and the even representation. How we are going to do that? So 0, 1 its equivalent binary is represented. Similarly 2, 3, 4, 4, 5 up to 5 all equivalent binary values are represented. So here we can identify that. So which are all the odd numbers in the equivalent binary representation, the bit which is at the 0th location is 1. As we can observe, 1 is an odd number. So in its 0th position, so bit is 1. 3 is an odd number. In its 0th position, the bit is 1. Similarly applicable for 5. Which are all the even numbers. In those numbers, at the bit 0 location, the value is 0. As we can observe, 2, the bit is 0 over here, so it's an even number. 4, the bit is 0 in the 0th position, so it's an even number. So any number you take, we can apply this concept. So in general, if LSB bit is 1, then it's an odd number, else it's an even number. So here we are going to deal only with the identification of the even number. Odd numbers we are not going to consider. So our aim here is to identify only the even numbers as per the question. So let us go through the same set of values and let us identify how it is being done with respect to the programming concept over here. Right? This is a typical theoretical example. Same we are going to replicate in the program later. Right? So let us take this as memory 1 and this as memory 2. So memory 1 consists of the array of input values, and in the memory 2, after evaluating the values of this array, we are going to store the even values in the memory 2. Right? So these are the values that we have considered. So 1, 2, 3, 4 and 5. Right? Now let us go through the evaluation procedure. So first value, it is 1. So if we convert that into equivalent binary representation, this is what we are going to get. So in this one, the LSB bit is equal to 1. So this is an odd number. So we are not going to store this number to the memory 2. Now the next value, it is 0, 2. 0, 2, its equivalent representation is here, and the bit 0 position, so it is having the value 0. So this is an even number. So we are going to store this value to the memory 2 location. So next is 3, its equivalent representation. So here at the bit position 0, the value is 1. So it's an odd number. So we are not going to store this. In continuation, we can observe 4, it is an even number. It has been stored to the memory 2. 5 is an odd number as per the observation. So we are not going to store that to the memory location. Right? What are the discussion we have done? The same thing is being represented here in the program format. Right? So we are going to have a consideration that the array of input values are stored starting from the memory location 30H, and what are the memory 2 we have considered in the example. So that is nothing but the memory location starting from 50H, where we are going to store the even values. Right? Okay, so let us start with the programming. So move R0 comma hash 30H, move R1 comma hash 50H. R0 and R1 are the memory pointers. Repeating again, R0 is the array of input elements. So it is going to be the memory pointer for that. R1 is going to be the memory pointer for the even values where we are going to store after evaluation. Right? So how many elements we are taking? So that's what 0, 5 are the elements we are taking. So move R2 comma hash 05. So R2 is going to be a counter. Now let us start with the looping part. So first value we are taking move a comma at R0. So the very first value from the array we are taking that to the accumulator. Then JB acc.0 comma skip. So this stands for jump if bit is set and that bit is accumulator dot 0. 0th bit position of the accumulator. If it is set, then go to skip. Right? So if that bit is set in the sense it's an odd number. So odd number we are not storing. Therefore we are going to the label skip and that label skip is over here. So then increment R0, then decrement the counter, then move back. Right? In case if the value in the accumulator it's a even number, then JB accumulator dot 0 comma skip. So that bit is set, then it will go to skip. If bit is not set, then it means for it's a even number, so then it will come to this location. So then move at R1 comma A. So R1 starts from the memory location 50H. To that location, content of the accumulator will be stored. Right? Then increment R1, then increment R0, then decrement the counter and it will come back to this loop until the counter becomes equal to 0. So now let us go through the simulation of the same program in the Keel software. So here is the Keel software. The same program has been typed over here. Now let's start with the execution of it. So initially what we require a set of values to be in the memory location, that is starting from 30H. So as you can observe over here, so here values are already fed. It is 0, 1, 2, 3, 4, 5, whatever the values we have taken the example, same values are being put over here. Right? Now let us start with the execution. So first instruction, move R0 comma hash 30H. So after execution, R0 is loaded with the value 30H. Then after R1 will be loaded with the value 50H. Then R2 will be loaded with the value 05H. Right? So now first value from the memory location pointed by R0, we need to move that to the accumulator. And that value, as you can observe, it is equal to 01. Right? So now let us see. Now the accumulator is loaded with the value 01. Then this is going to verify, this instruction is going to verify the 0th position of the accumulator is 1 or 0. Right? So this 1 is an odd number. In that case, the bit will be equal to 1. Therefore, it must move to the location skip. Now let us observe that. So now, right, now it has moved to the skip. So that means the number that is currently present in the accumulator is a odd number, and we are not storing the odd number, we are storing only the even number, right? So now, so it is skipped and then increment R0, decrement the counter, move back to the location, again repeat the process. Now second value is being loaded to the accumulator. The value is equal to 2. 2 is a even number. That means the 0th bit of the accumulator is equal to 0. So it has to store that to the memory location pointed by R1. Let us see that. Right, now it has moved to this instruction. So that instruction is the memory location starting from 50H. That is at this memory 2, as you can observe. All values are now, it is 0. Now the value from the accumulator will be stored to that location. So now as you can observe, the 2 has stored to the memory 2, that is nothing but the that is the starting memory location 50H. Now we increment R1. So increment R0, decrement the counter till it is not equal to 0. Move back and keep repeating the same process. The value is 3. It's an odd number. Take a skip. And then increment R0, decrement counter till it is not equal to 0. Move back. Then next value is 4. It's an even number, need to be stored to the memory location. It has stored. Then again counter decremented, the last value is 5, so it is a odd number, so it is not being stored. So now counter becomes 0, so stop the execution. So you can try the same with a different set of values. Thanks for joining.